you know. So in structure, think that way. How the load will transfer, how the load will go. If we don't have a load path, clear load path, then the load will find its own load path if we don't define. And then what will happen? Failure. If we don't define the load path, how to transfer the loads, the load won't transfer, you know, it's not magic. And then they will find, you know, that means there is no connection, and the load will try to transfer somehow, and that's how the structure fails. So we have to define this load path, and we have to make sure that that path has enough capacity to pass the load from one structure to another in equilibrium manner, right? So that's how. Now let's go. This is exactly the same here. It's a web splice, right? So all we have to do, talk about a 10 millimeter thick steel work. Usually in these clips, the steel plate here, it's in shear. And it's a 10 millimeter thick. As long as it's the same thickness as the whip, you're never going to have a problem with the plate itself. Or bearing, because those loads are quite normal. You can, of course, do the bearing checks, but as long as it is the same thickness as the whip, should be okay, right? So you were asked to calculate the eccentricity between the wheel group and the bolt group. That was one of the part. Just the eccentricity, nothing else, right? So understand the question, that only the eccentricity. So you have to find the centroid of the wheel group, centroid of the bolt group, that's it. And then what is the distance between the two? That's your eccentricity, and that's easy, 5 marks. Then the next is, the clit was initially specified with 6 millimeter structural purpose weld using E41XX electrodes by considering the eccentricity. You're late.
Sorry.
And the last day, it's okay. I didn't deduct you for those 3 dots.
Oh, thank you very much.
Okay?
Thank you for that.
No problem. So, the electrode size is given, everything is given. All you have to do, by considering the eccentricity in the joint, determine the adequacy of the specified weld to support the design load, and recommendation, any variation required. So, let's say the wheel fell, what do you need to do? Right? The recommendation. So that has 7 marks. The second part is the clit was initially specified with 4 M16 4.6S bolts. 4.6 is the grade. Okay? And one thing I noticed, you know, you put big bolts, M36, M32, M30, right? Big bolts and low grade. The problem is, the big bolts is the distances and tightening them. It's not easy, right? Especially these things will be done manually inside. Go for smaller bolts, go for fewer than, you know, go for more than fewer, right? Put more bolts, go for high grade, but stick to smaller diameter unless it's really necessary to go for bigger, right? Go for smaller, start with small first. So the second part is the clit was initially specified with 4M16 4.6S bolts, and the bolts holes are already drilled. So that is a trick, you know, it's already drilled. That means we have to stick to it. You know, we can change, but you know, I'm drilling inside with hand existing holes, it's not safe. It push, head back. If the, you know, the drill, when it rotates, if it's flat, you know, when it's an existing hole, sometimes it make little like hooks in the steel. It's not uniform, and then the drill can get stuck. And when it gets stuck to that sharp, I have experienced it quite a few times. And when it gets stuck, because I'm an ex-builder, so when I was an apprentice, I was young, didn't use this, you know, that's what happened. And it kicked back. And if it kicked back, you know, it can twist your hand. Those drills are quite powerful, you know, powerful than your hands, or the power that you have. So therefore, I mean, that is not the recommended way, or unless you will get the special tool. So let's say, in this case, we stick to those hole size. So it says that by considering the eccentricity in the joint, determine the adequacy of the specified bolt to support the design load. If the proposed bolt doesn't have enough capacity, means the connection will fail, so you have to do something, right? Doesn't have enough capacity, provide at least 3 recommendations. 3. If you don't do those recommendations, mean less marks, right? You have to think outside the square, right? So it's more about whatever I talk here, based on this, the answer will be based on this, what we talk, what I told you about, based on experience from the industry. So based on that, you have to answer that. Okay, so a bit of homework. If anyone has done some videos, listen to that. No, I'm just joking. Okay, now there is two formulas given here. You should be quite familiar with these. Now, let's go to the model answer. I hope we can do 2 papers. We are on the 3rd question. It doesn't matter even if you finish late today. It's the last day. Okay, so the first part, we have a design shear force of 108 kilonewtons, length of the horizontal wheel L1, mark them. And then another thing I found, and your assignments, and I keep telling this, please space your writing, right? Don't put the whole, like too compact. It's really, it's really hard, even you will get lost in it. So slightly space them. Paper is so cheap, especially for the assignment. If you can't afford the paper, go to the printers. Open the tray, get the paper from there.
You're not allowed. They lock it. They lock it.
No, there is still people around. They're not locked. Go to the library, get the scrap paper, reuse it. That's the worst case, that if you can't afford, go to the photocopy shop. They will have lots of scrap paper. They can give it to you, right? But how many pages? This 500 pages are $5. You can't use that in your entire semester. Don't have a pie one day, or have half one day, half another day, and that's your bundle of papers. I don't think anyone can afford. Everyone can afford. So better to just, and especially the exam, the paper is free, right? And the exam is free, so use it as much as you need. Doesn't matter, you have already paid for it. So L1, X1, L2, X2. So L1 is the length, L and X is the distance to the centroid, the horizontal centroid. Then, because vertically it's all in one line. So if I look at this weld group, so I need to know the horizontal centroids. Vertical, I'm not worried. It's all in one line because I'm not transferring any horizontal load. I'm just transferring the vertical load between the two sides. So that is what I'm worried. So this side, where is my centroid here? Where is the centroid here? And that's how I work it out. So then I worked it out. Simple formula. I'm not going to give you any formula for this if there is any in the exam. Right? This is your first principle that you have learned in the previous class. This is exactly the same, how to find out centroid of the area, or a triangle, or a square, or whatever. So practice those skills, right? It will come handy. If you don't, you may lose. Okay? So the weld group, that's the centroid. So the eccentricity for the bolt group, it's 4 bolts, so the centroid is right in the middle. If it's not symmetric, let's say there is bolt everywhere, you can easily find out the center of those bolts. It's again exactly the same like the weld. You just have to work out based on the first principles how to work out the centroid. So then, what is the distance? So E is the distance from one side to another side. So which is 100 plus 60 minus the weld group, X weld group, which is I just calculated here because I calculated from the left. So what I did, that's my origin here, and I calculated it somewhere here. There's the X distance. So then the distance is from here to here. So now I know this one here, which is 50 plus half of that. Oh, sorry, from here. So 50 plus half of that, that's 100. 100 from the center of the group to the joint, and then from the joint, so that there is 60 minus X. So 60 is the length of the weld minus X. So that's what I have done here. So 100 millimeter plus 60, that's the total length, and minus the weld group, distance to the center of the weld group from the left. So that's how I got 151, and then I'll find out the design M weld, and M bolt. It's exactly the same on both sides because eccentricity is between the two. So this is the moment that need to be resisted by the weld and by the bolt group in addition to the normal shear. And that was easy 5 marks. So now let's go in, the next one is the weld. So now the weld, the total length available is this much, 420 millimeter, and Fy, the vertical load in the weld, is simply the design divided by the weld equal to this one. You can do this one, or you can assume that the vertical in this case, because I only got the weld on one side. So in this case, I got the weld here, here, and here. When you have it on these 3 sides, then what you can do, you can just simplify. You can assume this to resist the vertical, and you can assume these to resist the horizontal. Right, I have done it, and then how you do, whatever that moment is, divided by this, that will be the shear in these both. Tension is equal to compression. That's how you do it. By that principle, that's easier. Easy way, quick way, right? You can do it that way. But if you have it on 4 sides, then you have to do this proper analysis, because then all 4 sides here, the centroid will be in the middle, and then all 4 sides are taking a shear. But in this case, because the centroid is quite close to the vertical, so the vertical weld is hardly taking any contributing to resisting the moment. So the moment is basically resisted by these 2 here. Okay? But I have done it that way, and you can do it both ways. Doesn't matter, I'll mark you right. So I have done, consider the entire weld, that's per millimeter. Then Fx from the moment, it's N weld divided by 0.3 times L1, and then calculated that's equal to 0.944. In this case, I have done that shortcut. So I have taken that and plus the moment only by horizontals. That is what I have done here. So that's the horizontal length. Then there's the resultant, Fy squared, Fx squared. That will give you the resultant in that weld. And then the capacity. So the capacity is this much, which is less than, so see the demand is higher, it's just because of the moment, so it's not good. Now I ask about, if it's not sufficient, what do you need to do? The weld is not sufficient, and therefore increase the weld size to 8 millimeter. You know, that's an easy answer, and then it's okay, because I asked you in the question. Now go to question 3C. So the number of bolts we had was 4. Design shear force is that. The first one is normal shear, right? Normal shear, that's just simply divided by the number of bolts. And then I know x1, y1, and it's a symmetric group. So it's simply times 4, right? So it's just simply, so see there's the formula. The connection is symmetrical, therefore sigma x square y square is equal to 4 times x square plus y square. So x square is x1, y square is y1 square, because it's all symmetric on all 4 sides. If not, again you just do add it both individually for all of them. 4 times x1 square y square is equal to this much. And then we go to the next. So the rest is the formula, it's given to you. So for the y it will be x, and for the x it will be y. That one there. This is it's the same. So the first one is the Fy, then Vx is equal to Fx, and Vy is equal to Fy plus, so this is due to moment, that's the normal, and then the resultant. So once I found out the resultant, the bolt sizes are given, it's less than the demand, so that means it's not good. So if it's not good, then these are the solution. Increase the number of bolts, use high grade 818S bolts, and the last one would be increase the hole size, right? Or increase the size of the bolt. So for size of the bolt, mean you have to increase the size of the hole, existing hole. So that's not the favorable method. So these two would be the favorable. So that's all about the connection question. Now let's go to the next question 4. So question 4 was about a glue lamp beam, a 450 by 90 GL10. GL10 is the grade. glue laminated beam has been proposed to support a joist timber floor. Floor joists are at 450 centers, provide continuous restraint to the beam laminated beam. Spacing between glue laminated beams are 3 meters. So now that 3 meters means something, the 450 means something, right? The load combinations are given. So critical ultimate limit state 1.2 G and 1.5 Q, where G is equal to 4, Q is equal to 3 kPa. So it's given in kPa, so you have to work out the UDL. The serviceability load conditions are given here as well. So all you have to go and find out calculate the ULS design action in the beam. Again, there's this easier 4 marks. Check the strength adequacy for this beam for ULS action, and check the adequacy of this beam for SLS action. So you have to find out deflection and moment capacity, shear capacity. That's all you have to find. The necessary formulas are given here, and the table that you need for the glue lamp, which gives you the bending, tension, shear, compression, and the modulus of elasticity, which is E. So let's go to the. So first of all, again, GQ is given, psi L, psi S is given, span is 4.8, tributary width is 3 meters, so that the spacing of the beams, there is a few beams, floor beams, so that's the spacing. Then you have to find out the UDL, which is the ULS UDL, that's 14.94. You don't need to do the other long term or short term. This is the one case is given, so you have to stick to that. So M design is equal to that, V design is equal to that. That's all. That's the simplest part. Then what do you have to do? The next bit is find out what is given, what you know, and the question. So that's B, D, bending, shear, and compression. Whatever you know is just write it down, and then the formula. So for the glue lamp, it's equal to K1, K6, K8, K24, FB, and ZX. So for glue lamp, we need to work out that K24. So ZX is equal to simple. There's the formula, reduction factor, K1 is equal to 0.8 based on the duration of the load. Now, I need to know the number of laminates. How many laminates are there? So they're simply divided by the thickness of each laminate. And then K6 would be from table 2.7, and that's how we, like the way we do for K4. So for glue lamp, it's K6. And then LAY, because we got the floor joist at 450 centers. So what those floor joists does, so we got a beam, and then because usually whether it's sit on top or sit on side, so because the top would be in compression, isn't it, for a simply supported beam. So that restrains the beam. Therefore, you can assume the length. If you look at a long section, let's say there's the beam. So the joist will be sitting here. Usually they're 240. So it holds the beam. It doesn't let it go. So it won't buckle. That compression edge won't buckle. Right? So therefore we can assume the LAY is equal to 450, and then based on the formula, the S value is 6.681, or you can use those figures, the D over B ratio, or B over D ratio, D over B, I think it's D over B, yeah. And then from the table, if it is less than 10, so K8 is equal to 1. So all these steps, you can see it has marks, and if you don't do it, simply you lose marks. So then we come K24. So K24, there is a formula given in section 8, which is section 8.7.7. The formula will be given if it's in the exam. And then again, this is the formula, so we already wrote there, and that will give us the bending capacity. Yeah, it's okay, more than the design or the demand, so we're all good. And we move to the next part. So the shear capacity, for shear capacity, K1, K6, everything remains the same. The only thing you have to work out is the shear area, which is simply 2/3 of the cross-sectional area, right? And 2/3 of the cross-sectional area, that will give us the C, 74.8. It's more than the design or the demand, and it's okay. Then the last check is the deflection. So for the deflection, Ix formula is given to you, so you can just plug in the numbers and can calculate the